If your Docker container talks to a database, a payment provider, an upstream API, it's going to need secrets, a connection string, a Stripe key, an access token. So how do these secrets get into the container? The easiest answer is also the most dangerous one. You bake them in. A .env file copied in next to your code, an env line in the Dockerfile, a build argument passed at Docker build time. It works on the first try, the app boots, and everybody moves on. The problem is that those secrets are now part of the image. They go everywhere the image goes. In this video, I'm going to show you how easy they are to extract. Then we'll rebuild the same image with those secrets injected at runtime by Infisical, an open-sourced secrets manager, so your image only has code, no secrets. Now here's how it usually happens. Your app reads its config from a .env file. This .env file is in your gitignore file. It never touches the repo, and locally everything works. And then we containerize the app, and the Docker file looks completely clean. No secrets in this file, but my copy copies the whole build context. There's no .docker ignore, and our .env file went into the image. Now, this isn't a rare mistake. Researchers scanned 337,000 images from Docker Hub and other registries, and they found that 8.5% of images had some secrets, many of them being private keys and API keys that were leaked. And a .env swept in by copy is one of the most common ways that they get in there. So let's build this and read the secrets back out. Okay, so I can just read back this .env file, and here I can see my secrets. Now you can see this is our full database connection string and our live Stripe key. And anyone who pulls this image could do this. And you can't scrub it out after the fact. People think they could delete .env in a later step of the Docker file. But layers are append only, so deleting a file later doesn't remove it from the earlier layer. Everything is still in the image. Run-rm hides files from the final file system. It doesn't remove it from the image. And the other two shortcuts from the intro are just as exposed. env lines and build arguments are going to be recorded in the image metadata. So Docker history and Docker inspect are going to print them right back. So to take a step back, baking secrets into your image gives you three concrete problems. One, the secret is everywhere the image is. Every registry you push to, every CI runner that builds on it, every laptop that ever pulls it, every backup and cache. Two, you can't rotate or revoke it. The value is frozen into the layer. So changing it means rebuilding the image and redeploying every container that's running it. That friction means that rotation gets skipped, and if a credential gets leaked, there's no kill switch. Three, you have no control and no record. We don't have an access policy on who can read each secret. We don't have an audit log of who pulled it. And there's no way to answer which image contains which secrets. Now multiply all three of these issues by every service, every environment, every tag. That, my friends, is secret sprawl. The same credentials in hundreds of images with no central source of truth. Now keep in mind, this is about the secrets that your app reads at runtime. Build time secrets like a token to pull a private package, this is going to be a different problem. And Docker already solves this with build kit secret mounts. The trap here is baking runtime secrets into the image. And the fix here is rather simple. Don't put the secret in the image at all. Here's how. The secrets move into Infisical. Infisical is a centralized store for your team's secrets with access control. We have audit logs. We've got rotation built in, and this is where every secret from now on in this video is going to live. Your image then ships two things, your code and the Infisical CLI. And this is a small client that fetches secrets from that store. When the container starts, the CLI authenticates with a short-lived token. It pulls exactly the secrets that this container is allowed to see, sets them as environment variables for your app, and then runs your app. The secrets live in your process for the life of the container and nowhere else. Nothing here is ever written into a layer. So this effectively solves our problems that we laid out earlier. The secret isn't in the image itself, so it isn't in any registry, cache, or laptop. You rotate it in one place in Infisical, and the next container start will pick it up automatically with no rebuild. And every fetch here is authenticated, scoped, and logged. And importantly, because the container holds a short-lived identity instead of a permanent key, you can cut this off whenever you want. So we have the same container and the same app, just that the secrets are gone from the image and they live in one place that you control. So let's build this out. Okay, so first, after you've created your Infisical account, the secrets themselves are going to live in a Infisical secrets management project. So I'll click here and I'll just use this my Python app one that I had already created. You can add a new project if needed. And these secrets are organized by environment and folder path. Now I'm going to choose the production environment. And here I've got my two, database URL and Stripe secret key. Now, in this paradigm, the container needs a way to prove who it is and prove that it's allowed to fetch these secrets. In Infisical, the way we'll do that is with something called a machine identity. Now, the machine identity is the same idea as this user account that I'm logged in with right now, except it belongs to a workload instead of a person. And much like my user account, where I had to put my username and password in, it needs credentials to log in. So in order to make a machine identity, I'll go over here to access control, machine identities. I'll add a machine identity to the project. and we'll give it viewer so that it can read our secrets, create it. And again, our machine identity needs those user credentials. I'm going to use this auth method, Universal Auth. Now, if I click on my Universal Auth, I have a client ID, and then I can also give my machine identity a client secret. Okay, so I've saved that client secret and I have my client ID. These are like the username and password for my container. Now, these aren't keys to any of my services. On their own, they unlock nothing except the ability to log into Infisical as one identity. And that identity can only read what I've scoped it to. So I've scoped it to this project, this environment, this path, and nothing else. So on the machine that runs the container, I'm going to put these two values into the environment. Here, that's my laptop. So I will export Infisical client ID, and then I'll export Infisical client secret. Now, the only thing that this holds is an identity that I can revoke. The real secrets are still in Infisical. Now, one note before we actually wire this up, Universal Auth is the platform agnostic option. So this works anywhere just like a username and password. But if you have containers that are running on something like Kubernetes, AWS, GCP, Azure, Infisical can authenticate using that platform's own identity instead. So in those cases, there would be no client username and password, no client ID and client secret. The container proves who it is with its native cloud identity. This is far superior, and we should do it wherever possible. But for today's demo, just for simplicity, we're going to use Universal Auth. So 2 changes. First, the .env never goes into my image again. I can actually just completely delete it. And here we have .env in our Docker ignore as well. Second, I install the Infisical CLI in the image and make the start command Infisical run. Now this fetches secrets and then it launches my app. Now note these install steps for installing the Infisical CLI I have grabbed from their docs. So I can look up Infisical CLI. And since I'm using Alpine, these are my steps. And you may have noticed there's another value that we need to fill in here. It says your project ID. This tells the CLI which Infisical project to pull from. So if I go back to my Infisical project, my Python app, if I click on my project settings here, I can copy project ID and I'll copy that over. Now this is not a secret either. And so what does this start command do? Well, it pulls secrets from the prod environment in Infisical. It then runs node index.js as a process that inherits them. The secrets never touch disk and they're gone the moment the process exits. Now note, these secrets are now officially living in Infisical. We've deleted our .env file. We could actually use the Infisical run on our laptop as well. So now we'll build it and run it. Now, in order to run it, the container needs a token to authenticate. So I'm going to mint one, a short-lived one from my machine identity credentials, and then I'm going to hand it as a single environment variable. Now, if this feels like a lot, there is a guide that goes along with this, and I'm going to link it below. So on Google, I'll just look up Infisical Docker entry point. And the guide will take you through how to actually set all of this up, create a machine identity, export the token, and all of those things. And I've already set these variables in Infisical client secret and in Infisical client ID. Now the CLI inside the container is going to pick up that token automatically, so I can run this. Now we can see here the app boots with a live database URL and a live Stripe secret key. And we can see they were fetched at startup. It says injecting 2 Infisical secrets into your application process. Now normally, of course, we wouldn't just print these keys to the console, but that's what my app is set up to do. Now let's rerun all of the same commands that leaked everything before. We'll open another terminal and we'll cat around for our .env file. We have no .env file. And if we were to Docker history or Docker inspect, all of these layers are going to come back empty. So I could push this image to any registry, public or private, and there's nothing sensitive to leak or steal. And if you don't want the CLI inside the image at all, it can also run on the host and inject the secrets at Docker runtime with Infisical export. So I'm going to put this doc in the description as well. So the image is clean, but pulling secrets at runtime isn't just about keeping them out of the image. Centralizing them is about closing the loop on those 3 problems that we started with. Remember problem 2, rotation. So in Infisical, I can change the value of DB URL. We're going to call this new. And I can restart my container, Docker restart my app. And I can see in the Docker logs that I now have this new Postgres value for my database URL. I didn't have to rebuild the image, nor do I have to actually touch the Dockerfile. Rotation went from redeploy and rebuild everywhere to edit one value. Now, problem 3 from the beginning was control and record. Now, every time a container fetches secrets, Infisical logs it. It logs which identity, which environment and path, from which IP address, and then, of course, at what time. So this question that we couldn't answer with a baked image, which container read this secret and when did it read it, is now this filter that we can look at in one place. And access, of course, can be set up with least privilege. So our machine identity can access only the secrets that we give it access to, and nothing else. It couldn't see another team's secrets, for example. And because that token is short-lived, we can remove role from the machine identity, and then this container's access is going to be gone on its next fetch. Now, if you wanted to take this a step further, Infisical can hand each container its own dynamic secret, so like a database credential that's generated on demand. It'll be scoped to the short lease, and then it'll be revoked automatically when the lease ends. If that token leaks, it expires on its own, and by the time anyone tries to use it, the credential is no longer useful. Now, a couple of quick notes on scaling this past one container. If you use Docker Compose, the same pattern applies to every service. And you could share one machine identity across the whole stack, or you could give each service one of its own. With separate identities, your web service and your workers are only going to see their own secrets. They'll show up separately in the audit log, and they could be revoked one at a time. Now, some apps don't read environment variables at all, and they expect a config file. And some need to pick up new secret values without a restart. And that is what the Infisical agent is for. This is a small daemon that runs next to your app. It authenticates with its own identity. It'll render your secrets to a file on a volume that both containers can share. And then it keeps that file up to date as values change in Infisical. Your app just reads the file and it never talks to Infisical at all. If you're on Kubernetes, don't wire the CLI into every image. Infisical has a dedicated Kubernetes operator. It's going to sync secrets into your cluster as native Kubernetes secrets with rotation and then auto reload already built in. As you can see, we have a video made on it, and I'll drop that in the description as well. So pick the method that fits where your secrets run. The rule underneath all of them is the same, which is that we want to fetch secrets at runtime instead of baking them into an image. At the end of the day, your image should ship your code and not your secrets. Baked in, they leak everywhere that your image goes, and you can't revoke them, you can't rotate them. Fetched at runtime with Infisical, the image carries nothing sensitive. You rotate in one place, and every access is logged. Infisical is open source and free to get started. I know that this was a lot, so the docs for everything that I've mentioned in this video will be linked below. If you have questions, drop them in the comments. I read every single one. Thanks so much for watching, and we'll see you in the next one.